Now that we know about hypothesis testing and estimation, let's focus on this last part on the estimators. An estimator is the function you use to get to the population parameter. And from the previous slides, we know that we are introducing an error. So the quality of the estimator is in itself a field of study. Let's look at this in more detail. We say an estimator is unbiased when it's centered. Same like we were talking about with the normal distribution and the t-distribution. So when you add the bias, if it's greater than 0, it means the estimator is positively skewed. If it's 0, it means it's centered because there is no bias. And if it's less than 0, it means the estimator is negatively skewed. The second property of an estimator is efficiency. We say that an estimator that has lower variance is more efficient. Remember when we're talking about confidence intervals? If we have a tighter variance around the mean, that means the estimator has lower variance, it's more efficient. The third property is consistency. This means that the limit when x tends to infinity of the expected value of the parameter will be the parameter, and that the limit when x tends to infinity of the variance will tend to 0. All this means is that ideally we want a parameter that is centered and with little to no variance. In reality, that's not what happens. So this is what's called bias-variance trade-off. Let's look at this graph. We have data points gathered from the population. These are our sample. So there is a degree of representativeness from the population in our sample data. And we are trying to come up with a model that can accurately predict a specific parameter from the whole population. If there is one takeaway from this whole course that I want you to remember is this concept. We are making an assumption and comparing it to the observed reality value. And because we are using sample data, we are introducing an error. So all the mathematics, models, it's going back to the drawing board and getting more accurate about reducing the error. It's all about optimization. We have an expected value and we have an observed value. So we are trying to reduce the difference between both.